All right, let's dive right in. Today, we are cracking the code on a problem that's so tough, it's literally used to separate the good candidates from the great ones at top tech companies. You're going to want to see this.
Yeah, you see that right. They say only about 10% of developers can actually solve this thing. This isn't just a puzzle, it's the kind of question that can make or break a high-stakes interview. It really shows how you think.
So what is this big, scary challenge? It's all about something called Wildcard String Matching. And trust me, this is a classic. If you're interviewing at any of the big tech companies, you've got a good chance of running into this one. Okay, so the basic idea sounds pretty straightforward, right? You get two strings. One is called the pattern. Think of it like a template or a set of rules. The other is the text, and your job is to see if that text fits the pattern. And that's it. The whole goal is just to say, yep, they match, or nope, they don't. A simple true or false. But as you probably guessed, the devil is in the details, specifically in how we handle those wildcards. All right, let's decode these wildcards. There are two key players here that turn this simple matching game into a real brain teaser. Let's meet them. Okay, first up is the question mark. He's the simple one. It just matches exactly one character. Any character, but just one. Easy enough. But then there's the asterisk. This is the troublemaker. It can match any sequence of characters. That includes matching nothing at all, an empty sequence, or matching a whole bunch of characters. This is where things get tricky. You know what? Talking about it is one thing. Let's look at a real example to see exactly how this works in practice. Okay, check this out. Our pattern is A star, B, question mark, C. And the text we're testing is aaabxc. So let's trace it. The first A in the pattern matches the first A in the text. Simple. Now we hit the asterisk. What does it do? Well, it can stretch to match the next two A's. Cool. So now we're looking for a B, and yep, there it is in the text. Next up is the question mark, which needs to match one character, and it matches the X. Perfect. Finally, the C in the pattern matches the last C in the text. See that? Every single part of our pattern found a perfect match in the text. So because we were able to make everything fit perfectly, the answer for this example is true. It's a match. All right, now your programmer brain is probably kicking in, right? You're thinking about loops and recursion. But hold on. Be really careful here, because the most obvious way to solve this, it's a trap. Seriously, just take a second. How would you code a solution for this? Especially for that super tricky asterisk. Your first instinct might be to just try everything, right? See if it matches 0 characters, then 1, then 2, and so on. Well, if that was your first thought, congratulations, you've just walked right into the brute force trap. And here's why it's a trap. Trying every single possibility for the asterisk leads to something nasty called exponential complexity. In plain English, your program's runtime explodes as the strings get longer. It'll be way too slow, it'll time out on any decent-sized test case, and in an interview, it's a huge red flag that you're not thinking about efficiency. So, if brute force is a total no-go, then what's the right way? What's the pro move? Let's shift gears and start thinking like a senior engineer. And this is absolutely key. You have to realize this is not a brute force problem. Your interviewer isn't just trying to see if you can get an answer. They're testing if you can find an efficient one. So instead of just guessing and checking over and over, the pro move is to use a much smarter, more structured approach. We're talking about powerful techniques like dynamic programming, where you basically build a cheat sheet to remember answers you've already figured out, or a really slick two-pointer optimization. Both of these are way, way more efficient because they don't repeat work. And honestly, that's the kind of thinking that separates a junior developer from a senior one. It's not just about getting the code to work. It's about finding the best way to make it work. And that is exactly the level of optimization that top companies are looking for. Okay, so we've looked at the problem, we've identified the big trap to avoid, and we've pointed towards the right way to solve it. Now, it's your turn. So are you ready to find out if you're in that 10%? You can go and solve this exact problem for free right now on Skillcef. Just go to the URL you see on the screen. It'll take you right to the challenge. This is your chance to try and implement one of those smarter solutions we just talked about. And getting started is super simple. Just open that link, sign up for a free account, make sure you choose the student role, and boom, you're in. You can start tackling the challenge right away. Seriously, there's no better way to really understand a complex algorithm like this than to get your hands dirty and actually code it. This is your chance to apply what we just went over. The best part is, the optimized solution is actually really elegant once you see it. The question is, can you find it? Good luck.